tokenization, lemmatization. What is the requirement for tokenization is when if you're trying to prepare a data to send to the model for a particular set of words or a set of data set, we need to pre-process it so that the data set size will be reduced and it's easy to transform the data for the model. The first step here it is in the Google Colab. If you try to open this Python file, we'll be sharing it. First we'll start with the installation of the NLTK library. You can use the command quotation pip install NLTK. After the installation of the library, next step is we'll go for the next pre-processing steps. That is nothing but how do you remove punctuation marks, stop words, which is a part of text pre-processing for the model. The first step is after the installation of the NLTK library, just import the library, import an NLTK, then import string module for the string manipulation and the regular expression module for the regular expression manipulation. There are download commands to use those punctuation functionalities: stop words, the word net, and average, receptron, tagger. Tagger are used for creating text tags, which are important in the future sessions. We will be discussing about it. This is a part of text pre-processing. Perceptron is a part of deep learning, or you can say deep neural network unit, which will be mainly responsible for the all tasks related to artificial intelligence to transform any data. This is similar to a human perceptron neuron. Similarly, sentence tokenization. This is where the main part is. Tokenization is splitting text or a data into array, which is very important for the future steps of text pre-processing to provide it for the model. Here in NLTK library, we'll be importing the tokenize module, and sent underscore tokenize is a main module which we'll be importing from the NLTK.tokenize class. Then we'll go for the word tokenize. This module is mainly used for the word tokenization. Sentence and is for lengthy sentences. We'll split into an array the whole sentences. Similarly, we'll split the words in a sentence to an array using this word tokenize. So here is a sample input statement like, hello all, I am Jack, welcome to the lab session. And you can see there is another sentence starting up. NLP is a very interesting area, which is so these are two sentences mainly if you talk about. Okay, we'll be using sent underscore tokenize command from the module sent tokenize, and we'll be giving the input as a statement which we provided in the above code snippet. So it will be as an output, the send tokenize command will give you the array of sentences. If you try to print them, you can see here the whole sentence is split into two objects of an array, which is comma separated here. Similarly, we have word tokenize command which will remove all the words from the statement, which will show you the words in an array. So say hello all, I am Jack, welcome. So all those are the words, just store it as an array, objects in an array. If you want to print the sentences, this is a simple for loop for a variable sentence we created, and the sentences array we got it from the above. In that array, we has the in operator will be giving all the individual sentence from the sentences array and store it in the variable. We'll try to print that sentence variable. So you can see two sentences are printed below. So you can see these are the output. Similarly, for the words, there is a word variable we created from the words array, and we are trying to print this words. So many words related to the sentences are available here. Now punctuations. How do you identify the punctuations? And we don't want punctuations in our output. This is the main agenda. So for word is for loop we are used here as a code snippet. The variable and from the words array we are trying to read each and every word, and we are comparing here and we are using the if statement, that is string dot punctuation. These are the punctuation, as you can see in this, it's been visible in the code snippet. These are punctuations which will match and will ignore them. This is the main agenda. So we are so next step we are trying to print those words which are without punctuations. So you can see all the words without punctuations. Next step is we were trying to we did it for the in the above step we did it for the same statement is repeated here. I'm trying to show you the similar concept here. Here it's showing in a comma separated way, and here it is showing as a simple word as line by line. So we got an array, we need an array, so that's the reason the code is looks different here. At last we need an array to give as an output to the model, as an input to the model. So this is another statement which can be used to generate as a array. Then we have a corpus database, which will be getting it from the NLTK main module, and we use the stopwords functional class from the corpus to uh, which has all the stop words. We match those stop words with our current input and we'll ignore them. So here just to help you guys, I have set the variable from the stop words, and will try to store all the stop words available in the English vocabulary, and try to print to show you with the print command. So these are the vocabularies you can see here. And the next statement, in the next statement we are showing how do you remove the stop words by ignoring them. So this is the normal if statement with the for loop, where we are ignoring the by matching with the English stop words which we gathered it from the above statement. So in the next step we are trying to print as an array all the all the at last we are getting an output without any punctuations, without any stop words. So this is our data set, which is now reduced in size from the above statements. Then we come for the lemmatization. Lemmatization is another step after tokenization, where we are trying to match the similar words to a root word. Like for example, cars, trains, and cars, trains are there in your cars, trains, and automobile. Suppose these three words are there in a sentence. We are trying to relate to automobile as a root word. This is an important step for the pre-processing. So we have something called as stem main module from the NLTK, where we are importing a class wordnet lemmatizer. We are creating a variable for that class, and from the for loop we were trying to use the command lemmatize for individual word is provided from our data set, and which will lemmatize and give you the show you, at last you will give you the words keywords with the with only root words. Not we are ignoring all the other sub words in this lemmatization process. Next is stemming. We'll learn the stemming in the next session. Thank you for all.